Good evening, sir, and all of my friends. First of all, let me introduce myself. My name is Emeninta Pelawi with ID 4213121015 from class PESP 21. In this video, I'd like to discuss about material and question on final semester exam of the basic nuclear course. In this video, the exam question have five materials. In the question number one, the topic is about radiative decay and half-life. In the question number two, the topic is about nuclear reaction and energy production. In the question number three, the topic is about radiocarbon dating. And in the question number four is about comparative decay rates. And in the question number five, the materials about nuclear model, which is liquid rock model and shell models. First of all, I would like to introduce about material in the question exam. And first material is about radioactive decay and half-life. Radioactive decay is a process which an unstable atomic nucleus loses energy by emitting radiation. A material containing such unstable nuclei considered radioactive. The decay can result in the emission of alpha particles, beta particles, gamma rays, or other particles. Half-life is the time required for half of the radioactive nuclei in a sample to decay. It is characteristic property of each radioactive isotope. The decay process follows an exponential law, which can describe by the following question, where the number of radioactive nuclei remain at the time t is equal to the initial number of radioactive nuclei times exponential to the power of minus decay constant times time. And the activity at the time t is equal to initial activity times exponential to the power of minus decay constant times time. And the decay constant is equal to the integral 2 over t half time. Next material in the question number 2 is about nuclear reaction and energy production. Nuclear fusion is a process where two like atomic nuclei combine to form a heavier nucleus, releasing a large amount of energy. This energy release is due to the mass defect, where the mass of the fused nuclei is less than the total mass of the original nuclei. The difference in mass is converted to energy according to Einstein equation, where the Einstein equation is energy is equal to mass times speed of light to the power of 2. And we can see from the equation and information about the equation or variables. Next materials is about radiocarbon dating. Have you heard about radiocarbon dating? Nah, radiocarbon dating is a method for determining the age of an object containing organic material by measuring the amount of carbon C40 remain. The carbon 40 is a radioactive isotope that decays over time. Living organisms constantly exchange carbon with their environment, maintaining a constant proportion of C40 to C12. When the organism dies, it stops exchanging carbon and the C40 begins to decay. Uh, the equation is like before, where the NT is equal to initial n times exponential to the power of the constant decay times time. The decay rate can be measured to estimate the time since the death of the organism. It's the advantages of we learn about the decay process. We can see or prediction about the death of the organism. Next material is about comparative decay rates. In problems involving multiple radioactive materials, we often compare their decay rates. This involves the understanding the half-life and decay constant of different isotopes. The example problem where the problems like given two radioactive materials P and Q with known half-life, we can determine how the ratio of their quantities change over time. By calculating the decay constant and use the exponential decay formula, we can check the change in their comparative amounts. And the last materials is about nuclear models, liquid drop models, and cell model. Liquid drop model treats the nucleus as the drop of incompressible nuclear fluid. It explains the average binding energy of nuclei and phenomena like nuclear fusion. The model includes the term of volume, surface, column, asymmetric, and pairing energy. The advantages of the liquid drop model, it provides a macroscopic view of nuclear binding energy and explores fission and fusion process. The disadvantages of liquid drop model, it lacks detail of individual nuclear behavior and cannot explain magic number in fine structure of nuclear energy levels. But in the shell model, describe the nucleus in terms of energy levels, occupied by nucleons, proton and neutron, similarly to electron configuration in atoms. Nucleons will discrete energy level. The advantages we learn about shell model, it explains the magic number and nuclear stability, accounts for nuclear spin, parity, and magnetic moment. The disadvantages of cell model, it complex calculation, especially for heavy nuclei, and requires adjustment for nucleon interaction. Now, next we discuss of exam question. The problem number 1 is the stone that Sambo has turns out to be made from the nucleus of element P204, which emit alpha particles with half-life of 120 years to become the nucleus of elements Q, which is stable. Comparing the P nucleus with Q nucleus is 5 over 11. The mass of P nucleus is 140 grams. 1 mu is equal to 1.67 times 0.1 to the power of 27 kilogram. Find A, the age of that sample amulet stone, and B, when the time needs to make the comparing factor of Q nucleus and P nucleus to become 5 over 11 of some amulet stone. First of all, we would like to write the given as an answer from the question. The problem above shows that the t-half of P204 is 120 years and the rate of nuclei of NP over NQ is 5 over 11. The and we can make the NP is equal to 5 over 60 and NQ is equal to 11 over 62. And in the problem, it says that MP is equal to 140 gram or 140 times 10 to the power of minus 3 kilogram. 1 amu is 1.67 times 10 to the power of 27 kilogram. And the reaction is about 204p and make reaction and becomes the 202 of Q plus alpha rays. And the question asks the problem about A is what when the T, P, and B when NQ over NP is equal to 5 over 11. T is, and to answer the question, the NTP is equal to an initial P times half times 1 over 2 to the power of T over T half. From the question, we substitute the NOP and we get the NP is equal to 5 over 60 times 140 gram is equal to 43.75 gram. The NP over 140 minus NO is equal to 5 over 11. 43.75 times 11 is equal to 140 minus N0Q. N0Q is equal to 43.75 gram. It means that 43.75 over 43.75 is equal to half to the power of T over T half 5. It makes the T is equal to 10 years. And when the NQ over NP is equal to 5 over 11, NQ is equal to 5 over 60 times 140 is equal to 43.75 gram. NQ is equal to 140 gram minus NOP. It means 140 minus 75 is equal to 96.25 gram. And Q over NOQ is equal to 1 over 2 to the power of T over half-life is equal to 43.75 over 96.75 is equal to 1 over 2 to the power of T over half-life, and it makes the T is equal to 137.4 years. And question number 2, the water in the Minahasa reservoir apparently contains the element hydrogen gas and its isotopes, namely H1, H2, and H3. For the water alone, it has a water discharge of 10 to the power of 6 meter cube per second and has been happening since 10 years ago and is stored in a storage pond. The H2 isotope has a share of 0.00241% of the total H isotope. Meanwhile, the H3 isotope has a slightly larger portion than the H2 portion. These isotopes are used as a fuel in a fusion-type nuclear reaction, with the reaction equation being H2 plus H3 long right narrow, and it makes the He4 plus N, where the mass of H2 is equal to 2.0141 U, and mass of H3 is equal to 3.016 U, and a mass of Ha4 is equal to 4.0024 U, and N is equal to 1.87 U. Decide A, the total amount of energy that can be produced by water from the reservoir, and B, if the electric power consumption of North Sumatra province is 4 gigawatt and the nuclear reaction efficiency is 0.75, so when will the total energy supply from the water of the dam end? And first of all, like usual, we write the given and ask from the problems. And the problems, we have the depth or the bit of the water, Q is equal to 4 times 10 to the power of 6 meter cube per second. H2 is equal to 0.00241%, and it's equal to H3. And T is equal to 10 years, and it's equal to 350 360,000 seconds is equal to 350 billion 360,000 seconds, and reaction is H2 plus H3 and makes the He form plus N, where the mass of H2 is equal to 1 or 1.0141 U. Mass of H3 is equal to 3.0161 U, and mass of He4 is equal to 4.0024 U, and mass of N is equal to 1.0087 U. X is about A total is about P. If P is 4 gigawatt and the efficiency is about 0.75, then when the times end, and the answer is NH2 is equal to 0.00241 over 100 times the 4 times 0, and H2 is equal to 0.00241 over 100 times 4 times 10 to the power of 6 meter cube per second times 350 billions 3 360 100,000 seconds times 1 over 2 times 0.141 U, and we get the MH3 in the water. From the equation we get the 3.001 times 10 to the power of 10 gram, and from the equation 2 we get the mass of H3 in the water is about 3 times 0.4 times 10 to the power of 10 gram, and we substitute it from to the equation, and we get the NH3 is about 1.00795 times 10 to the power of 10 meter cube per U, and energy released in the reaction is about delta M. We get the delta M is 0.01906 U, and we substitute in the equation where the A is equal to change in mass times the speed of light to the power of 2. We get the energy is equal to 70.74 MeV. So energy total from the equation of number of moles H2 minus energy reaction plus number of moles H3 energy reaction, we get the energy total is equal to 4.44 times 10 to the power of 11 megavolt. And for B, where the efficiency is 75%, we get the A is equal to 75 over 100 times 44.44 times 10 to the power of 11 megavolt. We get the energy is equal to 3.33 to the power of 10 to the power of 11 mV, and we substitute to the equation where T is equal to pay in over pay out, we get the theta T or time n is equal to 1.32 times 10 to the power of minus 11 second. That's the answer for the B. Next, we continue to the exam question number 3. The raffle stick is a stick made from the Jojo tree and is considered magical by the Mario trip on Tax Island. During life, the tree obtains the Che-40 isotope from the photosynthesis process. The proportion of the Che-40 isotope compared to the Che-12 isotope is 1.2 over 10 to the power of 11. Raphael mass is around 4.1 kilogram, and when the sample of 2.5 grams was taken, the activity of the carrot was detected at the 340 kbq decide a initial activity of Ch40 when the decide a the initial activity of Ch40 when the Jojo trees were cut. B. Why and how the comparison of Ch40 and Ch12 is a constant when a tree is alive. C. How old is Raphael stick if the epilepsy of Ch14 is 6,400 years. And like usual, first we write the given and ask from the problem. From the problem, we get the n for Ch14 over n Ch12 is 1.2 over 10 to the power of 11. And the activity is 340 kbq, and mass of the stick is about 4.1 kilogram, and supplicant is about 2.5 gram. And the problem asks a question. A. The initial activity of chair 40, and B. Why and chair 40 over n chair 12 is constant, and J. The time sticks or the age of stick, and the if the Ch40 is about 600 and 400 years. Now, to answer this question, first of all, we remember the activity time in the materials where the A is equal to initial activity times half to the power of T over half-life, and we substitute the initial activity where the initial activity is equal to the same constant times n0, and this k constant is ln 2 over half-life is equal to 0.6093 over 6,400. It's equal to 1.08 times 10 to the power of minus 4. And mj40 from the question we get from the equation is equal to 4.92 times 10 to the power of minus 11 kilogram. The initial activity from the substitute of the below, we get the initial activity is 1.6 to the power of 10 times 10 to the power of 8 dpm. And why is nc14 over nc12 is constant? The three fraction remain constant because photosynthesis use carbon dioxide from the atmosphere. When contains J40 in a concentration, as long as the tree is alive, the carbon dioxide taken from the atmosphere will have the same J40 over J12 friction as the atmosphere. Therefore, it remains constant. And for the question that asks the age of the stick, the age of stick we can get from the equation where the n is equal to initial n times exponential to the power of decay constant times t. We get t is equal to minus 6,979.36 seconds. Next, for the exam question number 4, there are two kinds of radioactive nuclear materials, that is P and Q. Initial the component factor of the three nucleus materials are 3 over 7. The half-time of the P materials is 5 days. After 70 days, the compression factor of three materials becomes 7 over 3. Find A. The decaying half-time of Q radioactive nucleus. B. The comparative factor of that both radioactive nucleus materials after 120 days. And when that both radioactive nucleus materials have the same comparative factor, and like usual, first of all, we write the given and ask from the question. The given is about NOP over NOQ is about 3 over 7. The half T half P is about 5 days and T is 70 days, where the rate of the NP over NQ is equal to 7 over 3. The problem asks A. Half time of Q. B. NP over NQ after 120 days. And C. T when NP is equal to NQ. To answer this problem, first of all, A, NP over NQ, we substitute into the formula where the NP over NQ is equal to 7 over 3 is equal to 3 times 1 over 2 to the power of 70 over 5 over 7 times 1 over 2 to the power of 70 times half of Q. And from the question, we get the half of Q is about 5 days. B, NP over NQ after 120 days. Like the problems above, we substitute into the question and we get the NP over NQ is about 3 over 7. C, T when NP is equal to NQ. It's, it's same, it makes sense. NP over NQ is equal to 1 and NP is equal to NQ. NOP times 1 over 2 to the power of T over half of B is equal to NOQ times 1 over 2 to the power of T over half of Q. We substitute the number of variables and we get T is 0 and it makes T is 0 days. The exam question number 5. There are two kinds of the well-known cool nucleus models as liquid drop model and shell model. Explain both and find the advantages and disadvantages of each model. And B. In a few of nucleus model have spin, parity, and the magic number, and the terms has in atomic shell too. Explain this term and find the two solved problem as it. Okay. The question asks about The advantages of liquid role model and shell model. And the question B, it asks explain term spin, parity, and the magic number, and find two solved problems. Liquid rock models treats the nucleus as drop of incompressible nuclear weight. It explains the average binding energy of nuclei and phenomena like nuclear fission. The model includes terms of volume, surface, column, asymmetry, and Poynting energy. The advantages of liquid rock model, it provides macroscopic view of nuclear binding energy and explains fission and fusion process. The disadvantages of liquid rock model, it lack of detail on individual nuclear behavior and cannot explain the magic number or fine structure of nuclear energy level. In cell model, it describes the terms of energy levels occupied by nucleons, protons and neutrons, similar to electron configuration in atoms. Nucleons fill discrete energy levels. The advantage of cell model, it explains the magic number and nuclear stability and accounts for nuclear spin, parity, and magnetic moment. The disadvantages of cell model, it complex calculation, especially for heavy nuclei, and require adjustment for nucleon interaction. Next, number B is the answer for the B problem. The term of spin, parity, and the magic number. Spin is intrinsic form of angular momentum carried by elementary particles, including nucleons, proton, and neutron, in a nucleus. The spin quantum numbers can be either integer or half integer values. For nucleons, the spin is about 1 over 2. Parity is a property related to the symmetries of the wave function of a quantum system under spatial inversion, changing the sign of the spatial coordinate. In nuclear species, parity is described as either even, positive, or odd. For magic number are specific numbers for nucleons, protons, and neutrons that result in more stable and tightly bound nuclei. These numbers correspond to complete shell within the nucleus, similarly to the electron shell structures in atom. The magic number are 2, 8, 20, 28, 50, 82, and 126. Nuclei with magic number of protons or neutrons exhibit higher stability, lower binding energy per nucleons, and are more resistant to deformation. And the two example of two solved problems. Example problem first, nucleus spin and parity. A nucleus with an odd number of neutrons when the last neutron is in an orbital with quantum number L is equal to 3, F of F is orbital, and S is half. Find the spin and parity of the nucleus. To answer the problem, for the last neutron in the layer of L is equal to 3 with orbital with S is half, the total singular momentum G can be get from the equation where G is equal to L plus minus S. G is equal to 3 plus minus half. It makes 5 over 2 or 7 over 2. Parity is given by minus 1 to the power of L. Here L is 3, so the parity is minus 1 to the power of 3 is equal to minus 1. Thus, the possible spin and parity is 5 over 2 and 7 over 2. For the example problem number 2, a nucleus with 50 protons and 82 neutrons. Determine if this nucleus is likely to particularly stable and identify the magic number. The given number of protons is 50 and the neutrons is 82 are both magic number. Nuclei with magic number of protons and neutrons are known to be especially stable due to complete filing of nuclear cells. So, the nuclei are stable. So, that's all about the discussion about materials and question in the exam. Thank you for your attention, and I'm sorry if there are mistakes in the vocabulary or in the PPT slide. And hope you and see you in the next video. Thank you.